The drive I'm replacing today is a Spectrum Weir 2 40 horsepower 480 volt drive. First thing I do is I usually make a video. This is my actual notes of where each wire goes. As you can see, they're labeled, and with the video you can always go back to it. Here I'm removing all the wires. Once you actually make a video of where everything goes, it makes the uninstall much quicker. This only took me a couple minutes to get everything out and cleaned up. I've already mounted the drive here. It's pretty simple. I used 1/4 20 bolts. One of the nice things about working on this drive is you can remove this top bar right here that's in your way so that you can access all the terminal blocks when you're putting in your 480. It's a nice, convenient feature. Here I'm using the Greenlee crimper to cut the wires, and then I use a knife to cut the insulation back. One thing to be careful of while you're wiring the drive is these washers behind the nuts are copper, and if you drop them down into the drive, you have to disassemble the drive and or unmount it, turn it upside down, and shake the washer out. So be very careful not to drop them down the drive. After I complete installing the big power wires, I then move on to the I/O. Down here there's one nice trick. These terminal blocks pull out so that you can wire them outside in your hand, so you're not bending upside down and backwards trying to put the wire in a terminal block, and then they just snap right back in place. It's a nice feature. It saves you a lot of time and prevents a lot of contortions. Here you may notice that the 480 fuses are not in. I did that on purpose. When I'm programming the drive, I like to turn the 110 on and leave the 480 fuses out. You do not need them to program the drive as long as the 110's on. So the next step for programming the drive is to go get the motor nameplate. So I like to take a photograph of this. Now that you have the nameplate information, you can start on programming your drives. The right arrow helps you go in menus, but be careful. If you hold the button, it'll skip through quite a few menus. So a light tap, a quick tap in order to change menus. The main display screen is diagnostics, so you have your actual speed, your actual armature current, your actual field. Then it'll flip to the other screen and you have speed reference, current limit, positive and negative, and what mode it's in. Now for programming the drive, we're going to hit the right arrow. It's going to bring us to run mode ramps. Up arrow will bring us to calibrations. Right arrow will bring us into the calibration settings. This is where you're going to input all of your nameplate information. For example, my drive is 84 amps, so I'm going to go ahead and turn this up to 84 amps. The next setting is current limit. On some applications, you're going to require 150%, which is the maximum this drive allows over nameplate, so it would be 150% of 84. In this application, I do not need that high of a number, so I'm going to go ahead and turn it down to 125. Then field rated amps. This is very important. The nameplate of your motor will have a field current. If it does not, you have to figure out approximately what the field current would be using Ohm's law or some other way. The base rated RPMs. This is fairly important. Most of your motors are going to be 1750, but there's a lot of circumstances where it's a lower or a higher speed, so program that into the drive. Next we have tach volts. This drive is running in tach feedback, so you'll have to program this to whatever the tach voltage should be. It goes clear up to about 200 volts, so I have 100 volt per thousand tach, so I'm going to put 175 volts, which comes out to 1750. Even though I'm inputting the tach voltage, I'm going to run the system in armature voltage feedback. It's safer and simpler so that you can test the polarity and the rotation of the motor without having an extra variable. Next, we're going to program the armature voltage. This motor is a 500 volt armature, which is pretty normal. So I'm dialing in 500 here. Then comes to, this is the line voltage. This has to do with low voltage trip. So you want this number to be below what your actual line voltage is. So here at this location I had about a 475 volt line, and I programmed that to 440. After you're done there, you're going to want to hit the left arrow and exit back to the main menu. Here we're going to actually save, so you hit the right arrow, up arrow, right arrow, up arrow, and you should see this screen right here, parameter save, and then it says saved. Next thing that I'm going to go change is the ramp times on this particular machine. It can be very devastating if it takes off to full speed, and I'm going to put that up to about a 15-second accel. Every machine is different. You need to know the application fairly well. If you don't know, ask the manufacturer or the operator or the owner. Someone needs to have some information about how quick this needs to accelerate. This is the stop ramp time. If you're doing a regen system, this is pretty important. So when the person hits the stop, how quick is it going to try and ramp down? There's two different ramps. There's your run mode ramps, which is your forward accel, forward decel, reverse accel, reverse decel, and then your stop ramps. Over here, I'm going to show the field weakening menus, where you could input a field weakening or a standby field so that when the motor hits stop, it'll actually still provide a little bit of power to the motor shunt fields, which will keep the motor warm. Often when switching from one drive to another, you're going to have to calibrate the meters. Here we go up to configurations, then in, and then down to analog outputs. Then we're going to go in, pick whichever analog output you happen to be using, whether you're doing a speed meter or a load meter. And I like to turn the offsets up to 100% and then go check the meter, or whatever percentage you prefer. Then go check the meter and see if it's outputting the correct number. You can then use a little bit of algebra to find out what you need. As you can see here, I actually have the polarities backwards. So I took and changed the polarities, and then I changed the calibration card, which is fairly simple to do, and we do keep those in stock too. Here we've actually completed the install, and the system is actually up and running right now. So you can see the speed reference on the left, and it's in run mode, and it's actually at 8% speed, 6% armature, and 100% field. Thank you for watching this video. If you liked it, please click the like button and subscribe, because we're going to have more videos like this, educational about AC and DC motors, drives, and controls.